Okay, so the next topic we're going to talk about is noble gas configuration. So it takes the standard electron configuration and makes it even shorter, especially for those that are like really long. Okay, so first thing is we need to know exactly where your noble gases are. So your noble gases on the periodic table is the very last column. So let's label it. So here are your noble gases, right? So all your noble gases, okay, except for the first one, most of your noble gases live in a p orbital or a p house. Helium is the only one that lives in an s house and s orbital, okay? So this is what you're essentially doing. You're going to take a part of the standard electron configuration and replace it with a noble gas. So the noble gas will take a chunk out of the standard electron configuration to make it shorter. So let's go through like a couple of examples together. So for example, how would you write noble gas configuration? You look at the first one and it says fluorine, right? So you look on the periodic table and find fluorine. And fluorine is here, right? It's element number 9, okay? So what you want to do is find the noble gas that comes before fluorine, okay? So a common mistake is a lot of people want to say neon, but neon is after fluorine. So the one before fluorine, the noble gas before fluorine, has to be in column 8 here is helium, right? So you would write helium in brackets like this. So helium is the noble gas that comes before fluorine, okay? So helium is going to take place of everything that starts at the beginning all the way to where helium is, okay? So where is helium? Helium is in energy level 1, and it lives in the s orbital, right? So it's in 1s, okay? In 1s, and it's the second one, right? So 1s2, this part right here gets replaced by helium, okay? Helium takes place of writing 1s2, so you still write everything that comes after it. So what comes after it is 2s2 and 2p5, right? So that's how you would write noble gas configuration. So I know you're thinking, well, that's not that much shorter, but it becomes shorter and shorter the longer the electron configuration is. Okay, so let's try sodium. Sodium is element number 11. It's here. Okay, so then you ask yourself, what's the noble gas that comes before sodium? So not after sodium, so it has to be a number smaller than 11, right? So the noble gas smaller than 11 is noble gas, that is number 10. It's neon. Right here, right? Okay, so let's think about where neon is located. Neon is located, right, in level 2 in the p house, right? So that means that all the electron configuration up to 2p is going to be replaced by neon. So right here, we're going to write neon in brackets, and we're going to replace everything up to 2p. All of this is going to get replaced by neon. So what you want to write after the brackets is what comes after neon. So after neon, so after electron number 10 is electron number 11, right? And that's sodium. Where does electron 11 live? It says it lives in 3s1, right? So you would write 3s1 because that's what comes after neon. So if you think about it, there are 10 electrons in neon, right? Plus the 1 electron in this is a total of 11 electrons, right? So let's do another example. The next example is nickel. And nickel is here, it's element number 28. So what's the noble gas that comes before nickel? So before number 28. It's not krypton because krypton is 36, that's after 28. So the one before nickel is argon, 18, okay? So argon is what you would write in brackets here. And you got to think about where is argon? What is argon going to replace? Argon lives in energy level 3, so like street 3. And it lives in a p house. All noble gases live in a p house, right? So everything all the way up to 3p gets all replaced by argon. So you still have to write what comes after it so we can actually get to nickel. So what comes after argon is 4s2 and 3d8, okay? Because argon is 18 electrons, right? That's what this number is, 18. So 18 plus this 2 plus this 8, right, is 28 electrons, and that's where nickel is, right? So the last example is rubidium. So rubidium is pretty far. It's right here. It's electron number 37. So what is a noble gas before rubidium? Electron 37. It would be electron 36 right here. It's krypton. So you would write krypton in brackets like this. Krypton is going to replace a bunch of electron configurations. It lives on level 4 in a p orbital, p house. So it's going to go all the way from the beginning all the way to 4p. All of this is going to get replaced, but you still can't forget what comes after krypton. What comes after krypton is 5s1. So you see how the longer electron configuration is, the shorter the noble gas configuration gets. Okay, awesome. Okay, so now we're going to talk about Lewis valence electron dot structures. Okay, so Lewis valence electron dot structures basically show the symbol of an element and how many valence electron it has. So valence electrons are electrons that are in the outside energy level. So we're ignoring everything on the inside. We're only concentrating on the outside. Okay, so there are 4 steps into determining how many dots or how many electrons we're going to draw. So you first are going to write the element symbol. So the symbol represents the atom's nucleus and the core electrons. So core electrons are everything on the inside. Okay, then we're going to determine the group number. Group number is the column number. Okay. So there are only 8 columns that we're going to be concerned about. We're going to not worry about the others. There's only 8 columns that we actually numbered. And the group column tells us the number of valence electrons. Okay, so this column number, group number, tells us the number of valence electrons. We're going to put a dot every 90 degrees until we reach the number of valence electrons. You cannot have more than 8 because there's only 8 columns. So if you look at the periodic table over here, okay, there's column 1, column 2, and you skip a bunch, okay? So all the ones in the middle have some weird valence shells that we don't really talk about until like unit 6. So we ignore those for now. And then there's column 3, 4, 5, 6, 7, and 8. So 8 columns, so maximum 8 dots. Okay, so if we go back, I'm going to do a few examples and then I'm going to show you the rest of the answers. So you're going to look for aluminum. So aluminum is here, right there. It's in column number 3, so group number 3, that's what they call it. So group number is the column number, right? It's in the 3rd column, 3rd group, so that means it automatically has 3 valence electrons. So you write the symbol, which was Al, and then you draw 3 dots. Okay, it doesn't matter where you start. So you can start on the left, the top, the right, or the bottom, as long as you put 1 on each side before you double up. So I'm gonna go ahead and just start here. So I'm gonna draw 1, 2, 3 like that, and that's correct. Okay, so if you decided to start somewhere else, you could do 1, 2, 3, and that's correct also. Okay, it doesn't really matter as long as you have 3 dots and they're 1 on each side. Okay. Okay, so next is fluorine. So fluorine is already here. I already circled it. It's in column number 7. So you're gonna end up needing 7 dots, right? So column 7 is group 7. Group 7 means you have 7 valence electrons. So you're gonna write F for fluorine. Like I said, it doesn't matter where you start, so it doesn't matter. I'm gonna start on the left. So 1, you draw 1 on each side. before you double up. So that's 4, 5, 6, 7. So it looks like that. Okay, so 1 on each side before you double up. So when you have 2 dots out like this, they should be drawn like there's an imaginary box around the element. Okay, so I'm going to show you some wrong examples first, and before I show you the rest of the other examples. Like if we were drawing fluorine, you can't just draw it like in like one big circle. That it's very unorganized, and we draw them in a very specific way for the future. So it's for a future purpose, okay? Also, we don't like windmills. So if you write fluorine like this and you do 1 on each side, you can't draw them out like some sort of windmill action, okay? So these are not right. Don't do it like this. Don't do it like this, okay? Like, you don't want to, like I said, you don't want to draw it messy. It has to be really organized, and you want to draw it as if you have like an imaginary box, okay? So what do I mean by the imaginary box? I'm just going to draw it somewhere over here. So if you have like fluorine, right, you're going to imagine that there is a box surrounding it, right? So there is an imaginary box, and you have to put the dots around it. So 1 dot, 2 dot, 3 dot, 4 dot is like they're all on the box. So 5, 6, 7. So they are on this imaginary box, okay? Obviously we don't draw the box, but you have to imagine that it's there, okay? So I'm gonna save a 1 bad drawing for helium. Helium is weird because helium is on what? So helium's here, it's element number 2, okay? So it's element number 2, but it's in column number 8. And so it's a weird one. It's in column 8 because it is a noble gas, okay? So it has to be there. But helium has only 2 electrons total, so it can't have 8. It's the only noble gas with 2. Because if you recall, when you draw your first energy level, you can only have 2 electrons on the first energy level. It's so tiny that it can't fit 8, just 2. So when you draw helium, okay, you cannot draw 8 dots here. So if you do this, then just know that this is wrong. Why? Because helium only has 2 electrons. It's the only noble gas that has 2, okay? So I'm gonna fill out the rest of the chart real quick, and then you can check yourself and see if you did it right. Okay, because I filled out the rest of the chart so you can like check yourself if you would like to, but I do want to show you the thing that's at the very bottom. So at the very bottom, it wanted us to write the electron configuration for arsenic, and arsenic is here. I accidentally covered it up, but it is electron number 33. So you had to have, you had to go all the way up to 4p, and it's the 3rd electron, so 4p3. So I went ahead and wrote it down for you here, okay? So a couple things that you need to know how to do when you are, you can have many different questions that are asked from this. So it might ask you like, how many valence electrons arsenic have? So you could just easily find that using the periodic table, right? Arsenic is in column number 5, so you know it has 5 valence electrons, right? So you would draw 1, 2, 3, 4, and then 5, right? Another way you can tell that it's 5 valence electrons is that you look for the highest energy, like highest number on your electron configuration. Highest number is this 4 and this 4. So this, there's a 4 right here, and 4s, and there's also like a 4p. So you look at that there's a 2 here and there's a 3 here. So 2 plus 3 is 5 valence electrons, right? So this 4 and this 4. So you ignore the 3 because it's on a separate level. It's not the highest level that is written down. So that 2 plus 3 gets you to 5 valence electrons, which is why you have 5 valence electrons there, and it's also in the 5th column as well. So I'm going to show you a couple of examples of like going backwards really quick. So I'm not going to do all of these, just maybe like 1 or 2 of each example. But if you look at the very top, it has the orbital notation already drawn out for us, and it's asking how many total electrons are versus how many valence electrons there are. So you have to be careful here because this is total and this is valence, okay? So there is a difference between the two, right? So total means like how many arrows do you have total, right? Valence is basically how many electrons do you have on the most outer, okay, most in the highest energy level, okay? So there are several ways to go about this. So now we're like sort of working backwards. So let's count how many arrows are in the first example. You have 2, 4, 6, 7, 8. You have 8 total electrons. If you have 8 total electrons, then according to the periodic table, which element are we talking about? 8 total electrons must be oxygen, right? So you write oxygen here. You can write O for oxygen, or you could write it out. So this is oxygen. How many valence electron does oxygen have? There's 2 ways to figure this out. The easy way is to just look at the column number and be like, hey, oxygen is in column number 6, so this number must be 6 valence electrons. Another way to look at it is that if you look at the highest level here, then there are 6 electrons in the highest level. So you would ignore the lower levels and just count that there are 6. Easiest way is to just look at, right, the column number. So for example, let me just do like the bottom one down here. So this one has a total of 5, right? Total electron, there's 5 arrows. So right here, if 5 must be boron, right? So you can write B for boron, or I'm just gonna go ahead and write boron like this, right? So boron has how many valence electrons? According to this chart, it has 3. So I just write a 3 here. If you're sort of looking for like the fancy way, then you would look at the highest energy level and know that there are 3 arrows here, because you would ignore that section right there, okay? Now, there's also a section where you have to like go backwards just by looking at the electron or noble gas configuration as well, okay? There are also several ways to go about doing this, so I'm gonna just teach you 2 ways. Okay, so this first example right here, okay? If it's a standard electron configuration, meaning that everything is written out, you could just count all the superscripts. This 2, this 2, this 6, this 1. So 2 plus 2 plus 6 plus 1 is, right, 11, right? So 4, 6, 11. So if it has 11 electrons total, then it has to be which element? So according to your periodic table, number 11 is good old sodium. So you would write that, hey, this is sodium. Another way to look at it, if you don't want to count, is to just look at the very last electron. Where is the very last electron? It's in 3s1. So level 3, so where is level 3? You found it right here. It's in the s orbital, the s house, and it's the very first electron in that s house must be sodium, okay? So let me do it backwards on this next example. I'll do this one right here, okay? So if I was to just, I was too lazy to count, and I just want to look at the very last piece of information here. It's 3d4. So I got to ask myself, where's level 3 in the d orbital, d house, and it's the 4th electron in that house. So I look. Remember, Ds are special, so I have my level 3 right here, right? In the d orbital, the d house, and it's the 4th electron going down. So this is 1, 2, 3, 4. So what's my answer? It's going to be chromium. If you wanted to go the long way and just like count it, then you could also do that. So what is 2 plus 2 plus 6 plus 2 plus 6 plus 2 plus 4, right? So 10, 11, 12, 18, whoops, I already lost count. 10, 11, 12, 18, 19, 20, 24, right? So electron number 24 is chromium. So it gets you to the same answer. The same thing works if you're doing the noble gas configuration. So if you were doing like this one right here, neon 3s2 3p2. So you have to be careful here. You can't just count the electrons because the noble gas shortened it. Okay, so you can do the same two ways, but I'm going to show you how you do that. The first way is to, like I said before, is to look at the very last piece of information, 3p2. So where is level 3? Level 3 is here in the p orbital, p house, and it's the second electron. So you have to count going in order. So second electron in 3p. So this is electron 1, then electron 2 would be silicon. So this would be silicon. Now, how would you do it the other way if you wanted to manually count? If you wanted to manually count, then you got to consider neon first. So neon has how many electrons? It has 10, right? So you have to include 10 electrons, right? So you have to include 10 and then add the 2 and the other 2. So you have 10 plus 2 plus 2, right, is now total of 14 electrons, and 14 electrons is silicon, right? That's silicon right here. So if I were to do that way for like this other example over here, so you have argon, 4s2, 3d10, and 4p5. Okay, so it has a noble gas, so you have to look for the noble gas. Argon is here. It has 18 electrons, so you have to consider that. So you consider that this has 18 electrons, right? Plus the 2, the 10, and the 5. So that's 20, 30, 35 electrons total, right? So where is electron 35? It is bromine, right? So you would put bromine here, okay? Or like I said, if you like to take the shortcut, you can do 4p5, right? So look at level 4. So here's level 4. It's in the p orbital, the p house, and it's the 5th electron if you're counting correctly. So it goes 1, 2, 3, 4, 5. It takes you to bromine. So there's just 2 different ways to go backwards, okay? So we're going to do more practice in a little bit. So there you go.